Hello, I'll be doing the 2017 modeling rate FRQ parts B and D. So the question asks, when a certain grocery store opens, it has 50 pounds of bananas on a display table. Customers remove bananas from this display table at a rate modeled by f of t equals 10 plus 0.8 t times sine of t cubed over 100 for the hours 0 to 12, where f of t is measured in pounds per hour and t is the number of hours after the store opened. After the store has been open for 3 hours, store employees add bananas to the display table at a rate modeled by g of t equals 3 plus 2.4 natural log of t squared plus 2t for the hours 3 to 12. So part B is asking you to find f prime of 7 using correct units and then explain the meaning of f prime 7 in the context of the problem. So the circle there here is f prime 7. So to find f prime 7, you need to derive f of t, which was the first equation given written out here. And you do this by the process of, VDU plus UDV. So VDU, you keep the sine of t cubed over 100 times 0.8. You derive u, in this case 0.8t, plus VDU, or UDV, sorry, 0.8t u. And then you derive this, so you use chain rule. The derivative of sine is cosine, and then you keep the middle, which is t cubed over 100, so cosine t cubed over 100 times 3t squared over 100, which is the derivative of this using chain rule. And then you plug in 7 in values of t, so sine of 7 cubed over 100 times 0.8 plus 0.8 times 7 times cosine of 7 cubed over 100 multiplied by 3 times 7 squared over 100. And that would get you an answer of approximately negative 0.8119. So in the context of the problem, it would be at time t equals 7 hours, the rate bananas are being removed at a decreasing rate of approximately 8.119 pounds per hour squared. So for starters, it's not just per hour because you're deriving. And how I learned it is you think of it in terms of physics. We know the position, velocity, and acceleration. So f of t is represented by velocity. And then when you're deriving the equation, you're turning into an acceleration. So if you think about it, that's decreasing at a rate of 0.8119 pounds per hour. That means slowly people are grabbing less and less pounds of bananas as the time goes on. And that's the answer. This is the second part of part B. Going on to part D, it asks how many pounds of bananas are on the display table at times t equals 8. So that's the work all right down here. We use the fundamental theorem of calculus for this one. And we know you got to start with the initial, how many pounds of bananas you started with, which it says in the problem, 50 pounds. And we also know the function g of t doesn't start until hour 3 because that's when they start adding bananas again. So we only integrate from 3 to 8 because we need to know the time at t equals 8. So we don't need to go beyond 8. And then for the function f of t, we do 0 to 8 because it starts right at 0. So for the fundamental theorem of calculus, well, the equation looks like the amount at hour 8 equals 50 plus the integration from 3 to 8 of g of t dt subtracted by the integration of 0 to 8 f of t dt. So you plug in g of t and f of t from the questions here. And then since this is a calculator question, you can just throw that into your calculator. And then I threw it in pieces. So I got 50 plus 58.964 subtracted by 85.617. And that gives you approximately 23.347 pounds. Also in B, you could just throw this in your calculator. To make it easier, you even could, on Desmos, throw in this and then the derivative, but I don't know how to explain that very well. So I just hand derived f of t in this. but that's parts B and D of modeling rate 2017.